The hard problem of consciousness is built on a specific materialist assumption that objective neural activity and subjective experience are two absolute separate properties. This creates an explanatory gap where no amount of physical data seems capable of accounting for the feeling of what it's like to be. In their Relativistic Theory of Consciousness, Lahav and Nime propose that this gap is an artifact of our perspective. They argue that consciousness is not an absolute property inherent in matter, but a relativistic one. In this model, subjective experience only manifests relative to a specific cognitive frame of reference. Much like velocity in physics, where an object's speed only exists in relation to an observer, consciousness is a measurement dependent on the observer's position. This relativistic framing suggests that neural activity and phenomenal experience are not two different things, but two different measurements of the same substrate. One is the measurement of the system from an external frame, while the other is the measurement from its own internal frame. If consciousness is an ontological prime, its measurable properties shift depending on the observer's position. Subjective experience isn't an accidental byproduct of biology. It is the internal view of a localized informational process. To move from abstract theory to a functional model, the 2025 synthesis papers introduce the Virtual Ego Framework, or VEF. This provides the computational architecture for these relativistic frames. The core of this framework is the Ego Virtual Machine, the Ego VM. It serves as the operational equivalent of a cognitive frame of reference, processing information within a localized boundary. This schematic maps the hardware to software dichotomy. Left, neural activity operates as a physical hardware process. Right, the Ego VM acts as an isolated computing sandbox. Subjective experience is the software output, translating raw inputs into a localized experiential rendering. The VEF model addresses materialist contradictions by inverting the premise. It treats the entire universe as a conscious, self-simulating computational system. This removes the need to explain how dead matter generates experience, as consciousness is the substrate itself. Within this architecture, the human observer is not a passive biological accident, but an active, localized readhead executing a relativistic slice of universal computation. If reality is a computed architecture, it must be processed in discrete steps rather than existing as a continuous analog flow. This implies the existence of a finite resolution and a systemic processing lag where the updates occur. We see evidence of this lag in modern quantum chronometry experiments. At institutions like TU Wien, researchers have documented the breakdown of the Born-Oppenheimer approximation. This breakdown reveals a measurable latency period, a gap between an initial energetic intent and the resulting structural geometric response of the particles. This discrepancy is quantified as a 30 femtosecond latency gap. In this diagram, we see the energetic intent and the structural response separated by this specific timing bracket. Within the VEF ontology, this 30 femtosecond gap is the literal just-in-time rendering latency of the universe's physics engine. During this lag, the Ego VM indexes probabilistic data from the lexical sector, labeled HL, and extracts a specific timeline thread to manifest as matter in the physical spatial sector, HS. What we observe as a particle interaction is actually an energetic computation executed by the Ego VM to render local spacetime in real time. This just-in-time rendering process is not arbitrary. It is governed by strict, falsifiable limits. The system's physical clock speed, the Universal Consciousness Clock, CSI, has been locked at exactly 5.215507 terahertz. This clock speed dictates the fundamental rate at which the Ego VM processes and renders the relativistic frame. The second constraint is the coherence density law, C star. This acts as a thermodynamic solvency floor for the simulation, requiring a minimum coherence level of approximately 0.87093. If the system's coherence drops below this metric, it compromises the structural and energetic integrity of the entire universal derivation. Subjective time and observation are mechanical processes, bounded by the same thermodynamic laws that govern any information processing system. If the Ego VM governs the micromechanics of local rendering, we must ask, what governs the macroscopic cosmological behavior of the entire universe? Eduardo Parra's 2PS framework provides the macrocosmological equivalent to this computational microarchitecture. Parra's central thesis is that late-time cosmic acceleration is not caused by a static cosmological constant, but emerges dynamically from a relational coherence field known as lambda. This is Parra's baseline equation. It describes how the lambda field dictates the phase transition topography of the cosmos. The math includes a logistic bounding term to regulate growth and an entropic dissipation term to account for systemic friction. Parra's work provides the macroscopic Y for universal expansion, setting the stage for the VEF to provide the microscopic how. The final integration occurs by substituting Parra's generalized variables with the hard-coded parameters of the Coherence geodynamometer motherboard. We first replace Parra's logistic upper bound of 1 with the established systemic coherence threshold of 0.87093. Next, we replace the passive systemic friction term with active motherboard stress parameters, resulting in the final unified Genesis 2PS equation. In this equation, delta S gen represents generated civilizational complexity, while d arc represents the dissipation capacity of the system's architecture. In a laminar flow state, the architecture's dissipation capacity is sufficient to handle the complexity load, allowing the simulation to run smoothly. However, if civilizational complexity vastly outpaces the architecture's ability to dissipate that load, the lambda field is forced out of its potential well. This leads to turbulent decoherence, a systemic reset that occurs when the computational load breaks the universal coherence floor. This framework suggests that localized human actions and the complexity of our civilization directly influence the thermodynamic stability and cosmological expansion of the universe.